Hello, class. I never know if you're watching in the morning or the afternoon. It is good afternoon here. I'm trying to beat the sun before it starts coming in the window here off to the side. So hopefully I can squeeze this whole video in before the sunlight hits the whiteboard. Today we're going to look at the very last section in chapter 7. So that's why it is not its own chapter as far as testing goes. I combine it with chapter 6. Hopefully that'll alleviate some of the pressure of all of those fractional problems, and this will help balance some of those things because these are not all fractions. And so this very last lesson is 7.3, and we're going to look primarily at the graphs of different types of functions, and then as a bonus look at two different types of application problems with linear equations. So perhaps some of you have done some of these things before, and then we do just a tad bit about not linear equations. So I am trying to get out of the screen so you can copy these things down. Obviously you can pause at any time. So first type of function we're going to look at is linear. As you can tell, it has what the graph looks like right there in the word linear. So these are graphs that are straight lines. There are three different forms. We call this form the standard form. We call this form the slope-intercept form. And this is the one we use primarily for graphing purposes. And then this form here is called the point-slope form. The m is the variable that's designated to be the slope. So I see here that I didn't include that. Slope is kind of how steep our line is. So whether we're going, well, from my perspective, this is uphill, downhill for you. Whether it's more flat, as steep as it is, that is what we mean by slope. And so I sketched out what each type of slope that is possible. If you have a positive slope, it tends to rise from left to right. If we have a negative slope, it looks like it's going down when we read from left to right. If we are driving along a flat road with no slope at all, no incline, we would have just a flat road, and so we would say we have zero slope. So horizontal lines have zero slope, and then vertical lines that go straight up and down. These are not functions, so we don't do anything with this other than mention that yes, there is this type of line. It is not a function, so we don't look extensively here, but technically these are undefined slopes. All right, so 4 different possibilities for slope. If you're given 2 coordinates, you may remember the slope formula here from past math classes. We talk about how it's the rise over the run. So the top number in our fraction is going to be how far up or down we went. The bottom number in our fraction run goes straight across. So our x's that run straight across here are on the denominator of the fraction. In these formulas here, we denote m to mean slope. Just going over that one more time. All right, so here's our first example of the day. We're going to graph. We're not in any of these forms right now, really. We're kind of in slope. We're almost in slope-intercept. We're not really in standard form at all. And so the first thing we want to do is convert to this slope-intercept form. And so that kind of translates to just solving it for y. We need to get y isolated, or by itself on the left. So let me just rewrite our equation here. And so the only thing really preventing me from having y by myself is the fact that I have multiplied it there by 4. So to undo multiply, we divide. And then we're going to simplify as much as we can. So 8 over 4 is 2. All right, so now that we have it in slope-intercept form, what do we do with it? Well, you're always going to graph the y-intercept, which is denoted as b, first. So the very first step, or maybe it's even better if I write it like this. 1, graph the b. So in the form y equals mx plus b, b is the constant that shows up at the end of the equation. It is where this line will hit our y-axis. So we're going to go up 2 spaces and put a dot. All right, so whatever that number is, we go there first. Once we've solved for y, we go there first, we put a dot. So if this was a -5, you would go down 5. If this was a 0, you wouldn't go up or down any, you just stay right there at the origin. If this was a +10, we would go up 10 spaces. Whatever that number is, you do first. All right, 2. From the y-intercept, so at the place where the dot is, we are going to count out the slope. Remember, it's rise over run. So you do not start here at the origin. You start at the dot where you put the y-intercept. So our slope is -3 over 4. So that's why I wanted to give you this visual here, because the slope is negative. So you should anticipate it slanting down from left to right. So it's rise over run. So we need to go -3 spaces, either up or down. Because it's negative, I am going to go down 3. So down 1, down 2, down 3. Now don't put a dot there yet. We still need to handle this +4. So it's rise over run. We're going to go down 3, but that 4 is positive. So given the choice between left or right, we're going to go right 3 spaces because that is a positive x direction. So down 1, down 2, down 3, right 1, 2, 3, 4, put the dot there. You can do it again if you like, down 1, 2, 3, estimate 1, 2, 3, 4. We could go up 3 and left 4. And once, you really only need 2 lines or 2 dots. You can do a few more if you wish, and then try to make it slightly straighter maybe than I have made mine. I wanted to make sure it caught all the dots. When in doubt, just make your line a little thicker here so it connects all of those dots. It definitely needs the arrows because your line does continue forever in both directions, and you want to avoid doing this. It is not just a graph of the points between this dot and this dot. You want to make sure that you continually indicate that that will go forever. All right, let's do another one. So my next example, let's already have it solved for y. Let's do y equals 2x. So once again, all right, so it already has y by itself, which means it already is in slope-intercept form, but this one doesn't look like this model quite yet. We do have the y, the equal, we have some number in front of the x. This time it's not a fraction. We can make it a fraction easily enough, and there is no b. So think about what number represents nothing, and if you want, you can put in a +0 right there, And that might make that a little bit easier to graph. It's not going to come to you with the 0. You'll need to know to add that in. So for the y-intercept, when we do that piece first, you're not going to go up or down any. You're just going to stay right there at the origin. And then from that red dot, my slope is 2 over 1. So everything is positive. So I'm going to go up 2, right 1. Up 2, right 1. Keep in mind, I didn't elaborate on the last example, but a positive 2 over a positive 1 is the same thing as a negative 2 over a negative 1, because of course two negatives make a positive. And so if you, instead of going up 2, right 1, there's also going to be points on this graph that are down 2 and left 1. And so you can see when I double negative and go down and to the left, that's still going to line up with the rest of these dots. Well, if I can. My ability to draw on my own whiteboard here is not great today. So let's do one more, maybe a couple more. Maybe one to try. Or a couple to try. Let's look at one like this. Let's make it 5x, my bad. Let's erase that there, 5x. And then we'll make it plus 10y equals negative 30. So if you'd like to solve that for y and give that a try, it definitely has an extra step compared to that first one I showed you. So we need to get y by itself. So that's the piece that wants to be isolated on the left-hand side of the equal. So we're going to subtract 5x to the other side. We need to get that guy away by doing the opposite of addition. These are not like terms. Because our formula is y equals mx plus b, I'm going to write the negative 5x before the negative 30. So it's going to be something x and then a constant number in the back. Divide by 10, divide by 10, divide by 10. So y equals 5 over 10, or negative 5 over 10 reduces down to negative 1/2 x, and then we have a minus 3. Think about what it is we're going to do first. Let me check the lighting. Yep, the sun is just starting to come in. I didn't make it. I'll try to just continue on this side of the screen here, or the whiteboard. All right, we're going to go down 3. So down 3. And then you can assign the negative to either the top of the fraction or the bottom of the fraction, but not both. So you're either going to go down 1, right 2, or you're going to go up 1, left 2. It's a negative number, so your slope needs to slant down. It's a little bit flatter than that last one. Oh, look at my nice line there. Well done. And so that is the graph for that. All right, the only other type of graph you might see, and if you need additional examples, I'm sure there are some videos in my math lab to help you through the homework. There's also a ton of YouTube videos. If you just need a little, like a few more to watch, just YouTube graphing linear equations or linear functions, and you will get more examples than you would ever want to watch. The last type that we're going to look at looks like this. And so you notice here, you don't even have an x. There's no x value. So if I was going to rewrite this in slope intercept form, there is no m, and so therefore there is no x. And so what number, again, means nothing, 0. So it's almost as if you have no slope. Well, when you go down here and you look at which graph has no slope, it's going to be a flat horizontal line. It doesn't slant up, it doesn't slant down, it just stays flat. So, when you only have a number and you have no x, you know without a doubt that's going to be a horizontal line. How do you graph a horizontal line? Well, you go to wherever that number is on the y-axis. So up 1, up 2, up 3, up 4, and you just make it look like that right there, a horizontal line. Regardless of what the x value is, y is equal to 4. If this was a -2, I can do a few of these on the same graph without really too much problem. If this was a -2, you would go down 1, down 2. And so you would just have a horizontal line through whatever this number happens to be. All right. We have a couple different types of word problems we're going to look at. But the last thing before we get to that, we need to talk about domain and range. Of linear functions. The domain is always the set of all real numbers, or written as your book. I did see when I was looking some things up, your book definitely does utilize that notation. X such that x is all real numbers. So I'm not sure why MyMathLab is so attached to this, but you don't have to type it, it's already embedded in there for you, so that's good news. And your range is typically also all real numbers, or y such that y is a real number. I just didn't want to write that all out. The only exception to the rule is that horizontal lines have a range of one set. So the range is just the set of whatever the number is, not a hashtag, whatever the number is of the equation. Let me elaborate real quick. All right, this is my own shorthand just to save us time of writing that out. So if this was my equation, I was going to graph y equals 1. I would go up 1 on the y-axis and draw a flat horizontal line. And so because this is 1, the range of this would be the set, and 1 would be the only member in the set. Because regardless of what x value I plug in, the y value is always 1. And I did do one example like this in the last in 7.2. So you have another example of that there as well. All right. So that's all the graphing. We have 2 word problems we're going to look at. They're both in your online version of your textbook. So, but I would assume the numbering is the same as my hard copy version, but I will hit the highlight so you can just take notes directly from the board. Let me make sure if I write here, I've always tried to avoid, it's not great. So How about to be continued? And I'll wait till the sun passes and I will continue this. So we'll have a part 1 and a part 2, and that way I don't lose any of you due to glare. And so I will upload 2 different videos after the sun kind of makes its pass through the whiteboard. So stay tuned. Thanks.